Hello everybody, welcome back. We are on 4.4, the quadratic formula. What we're going to do today, you may remember in Math 11 when we looked at taking the law of sines and law of cosines and we derived the formula. So instead of me just giving you the formula, we derived it. Well, I think I do recall mentioning that we will derive the quadratic formula in Pre-Cal 11, and so here we are. So the quadratic formula is derived from the equation in standard form. So you'll notice that I have ax squared plus bx plus c. So I've rewritten the equation. Here we are. And so what we're going to do is, the first thing we're going to do is to derive the quadratic formula, because what we want to do is we want to solve this for x, right? And we can do that with numbers. We plug the numbers into the quadratic formula. However, this is where the quadratic formula comes from. So we're going to do the variables. Our goal is to get x all on one side. You're going to notice that it is obviously x is here twice, so we've got to be a little bit creative. So the first thing what we're going to do is we're going to divide the a values. Step one is divide each of the four terms. So there's four terms here. There's the ax squared term, there's the bx, there's the c, and then there's the 0 on the right hand side. So we're going to divide each of the terms by a. So here we are. So I've divided every term by a. When I do that, it simplifies to x squared plus b over a x plus c over a. And then it's obviously 0 divided by a is just 0. Our next step is going to be to get rid of the plus ca. We're going to bring that to the right-hand side, so we're going to subtract it from both sides. In doing so, we get this, all right, minus this. So then where this part comes from, that I have highlighted here, this is completing the square. So we subtract the ca, put it on the other side. We've learned that when we're completing the square, we do this with equations. And what we do is, when we complete the square, we take half of the coefficient, which we did. So b over a would be equal to 1/2 b over a, or b over 2a, and we square it. And what you do to one side, you do to the other side to keep it balanced. That's the first step. All right. Next, what we're going to do is, well, I'm going to change this into a perfect square, and then I'm going to find a common denominator over here. Okay, here we are. So, sorry, I've squared this first. Okay, I've squared these two terms here first. And then what I'm going to do is I'm going to take this and I'm going to write this as a perfect square. So this becomes this, just like we did when we had x squared plus 2x plus 1. That becomes x plus 1. This is the same idea, only we have variables and not numbers. Okay? And simultaneously, what I've done at the same time is I found a common denominator here. So to this term that I have highlighted to c over a, I had to multiply it by 4a in the numerator and denominator to get a fraction with the denominator equal to 4a squared. My next step is to take the square root of both sides. And I'm going to write this as a fraction of just over 4a squared, which we have right here. Now what I'm going to do is take the square root, like we did in some of the earlier sections in the chapter. Alright, and then our next line, once we take the square root of anything squared, of the square root of anything itself squared, it's just going to be itself. So we left with x plus b over 2a. And remember, if we take the square root here, we take the square root of the numerator and the denominator. Remember, this can be plus or minus. But once we take the square root, we know the square root of 4 to minus 2. It's the same idea here. So we put a plus minus in front. So we're going to square the numerator. This looks familiar. Yeah, you're right, it does. And then the denominator, we're going to take the square root of 4a squared, which is a perfect square, 4a squared, and it's going to be 2a, which is the same denominator as over here. Interesting. So, remember, we want to get x by itself because that's the goal. That's why we took the square root of it. So we got x by itself. So we're going to take the minus b over 2a over, plus or minus. I've taken the square root of the denominator here, and I've got 2a. And now I just put the plus or minus. I have a common denominator in both, and what we end up with is the quadratic formula. So that's excellent. We've come up with the quadratic formula. I'm not going to make you do that again, by the way. But it's nice to know that they just didn't pull it out of thin air. What they've done is they've actually taken the standard form of an equation and rearranged it for x using the completing the square, taking the square root, which we've learned in chapters 3 and in chapter 4 as well. And we come up with it. So that's where the formula comes from. So I just want to share that with you instead of just giving you the formula and sending you on your way. All right. So the first example on page 12, what we're going to do is we're going to use the quadratic formula. I'm just going to put the answers up because this is something we've done in the past. So I have 3 questions here. Remember, you make sure it's in ax squared plus bx plus c equal to 0 form, and then you use the quadratics. The key is it has to be equal to 0, right? And it should be in the form ax squared plus bx plus c. You'll notice in this first one I put a is equal to 3, b is equal to 5, and c is not equal to 11, it's equal to negative 11. You take the sign to the immediate left, obviously. So we plug everything into our formula, and we get, these are exact answers. So when I ask you to find the exact value, this is what I'm looking for, and if it doesn't, you can put them in decimal form if you wish. Okay? Example B, I just have the answers for you. You can try that on your own, please. Okay? And C, I did it again, and the reason I did C again is because I wanted to look at this step here. And this step is where we are going to simplify the radical. So in the first example, A, 157, that was actually it doesn't have any perfect square factors. It's actually a prime number. Okay? And here, same with the radical, the square root of 17, same idea. It's it's a prime number. It doesn't have any prime factors. But if you look at this one, 8. 8's interesting because you'll notice that 8 has factors 4 and 2, so we can take the square root of 2, and you may remember this, or at least you should, that the square root of 8 can be written as 2 root 2. This is automatic. You should be simplifying your radicals, and then it simplifies nicely down to 3 plus the square root of 2 and 3 minus the square root of 2, because we have 2 plus or minus 2, so that 2 in the denominator, the 6 is divided by 2 and you get 3, and the 2 divides by 2 and you get 1. And you can also check these very quickly. I'll bring up my Desmos program for you. Remember your desmos.ca or .com, sorry, desmos.ca or .com. We plugged it in, so I'll plug that first one in. Y equals 3 x squared plus 5x minus 11. I know we set it equal to 0 because we're looking for the x-intercepts because that's the solution when that y is equal to 0. And you'll notice we get the 2 answers that we have on our page, so negative 2.92 and 1.26. And that's what we had here, or 1.25, depending on your roundage. 6 in, right? And it's very easy to check these. Same with this. Question B. You can plug that in as well as, let's see, it's just another way to verify, right? That's nice. You can plug it in the graph calculator. Instead of putting in 0, you put y equals when it's equal to 0, because that's essentially what you're looking for. These values are when y is equal to 0, right? So you can use your calculator. Okay? And then we have a word problem here. So I'll bring the word problem in. The word problem says the height of Peace Tower in Ottawa is 90 meters. If an object is thrown downward at 5 meters per second for the height, time t seconds the object takes, find the errors using the quadratic formula, because we're in the quadratic formula section. Again, this is review. You plug everything in and you solve your two values of t. In this case, we get a negative t value and a positive t value. You've noticed I've x'd out the negative t value, and the reason I've done so is due to the fact that we can't have a negative time, right? So, and we're getting a negative value because the initial height is 90 meters, right? So you guys are aware of this. This is a review. We've done this in the past. So the homework is found on page 254, and we're just do a few just to make sure we're getting the hang of these. And these are numbers 3, 4, and 5. Okay. All right, and we'll see you in the next video when we're going to do the second part of the section on the quadratic formula. And we're going to talk about the discriminant. All right, thanks everyone, and we'll see you again soon.